All right. So this is question number 6A from the homework. And in this question, the question reads, it says, in the diagram above not drawn to scale, O is the center of the circle. Angle AOB is equal to 130 degrees. Angle BAE is equal to 30 degrees. ACE and BED are chords to the circle. Calculate the size of each of the following angles, given reasons for each step of your answers. All right, so the first one is angle ACB. This is angle ACB, this angle here. So I would start by saying that angle ACB is equal to 130 to that divide by 2, which is equal to 65 degrees. And this is the reason angle at center is equal to 2 times angle at circumference. Now, how do you identify angle at center versus angle at circumference? So this is 65. Please look how. Now, please note the two angles are angle ACB and angle AOB. You'll note that both angles start at the same point. They both start at A. They both end at what? B. One goes to the circumference, that is C. The other goes to the what? Center. The angle at the center is called angle at the center, and the one at the circumference is called angle at the circumference. The angle at the center is 2 times the angle at the circumference. So if the angle at the center is 130, the angle at the circumference, ACB, is 130 divided by 2, which is 65 degrees. Let's have a look at another angle. The angle is angle CBD. Angle CBD. This angle here. Now, we already said earlier that angle CBD is equal to 30 degrees. And the reason is that they are angles in the same segment. They're angles in the same segment. So let me show you how we identify angles in the same segment. Now, if there was a line connecting C and D, that would be a chord. So if there was a line connecting C and D, all right, I'm just trying to erase it so that I can draw a better one. If you had a line connecting C and D, that line is called a chord. Now a chord divides the circle into segments. So over here, the shaded section is a small segment, and everything over the other side is another segment. So now, angles at the same segment have the same starting point and the same ending point, and the angles are formed at the circumference in the same segment. So one is CBD, and the other one is angle CAD. Both have the same starting point and ending point. On both start at one end of the chord and end at what? The other end of the chord. And the two angles are formed at the circumference in the same segment. Now those two angles are called angles in the same segment. You have angle CBD and there's angle CAD. Both start at one end of the chord, go up to the circumference, and then come back down to the other end of the chord. The two angles are equal. They are angles in the same segment. So if this angle here is 30 degrees, this angle here is also 30 degrees. Angle CBD is equal to 30 degrees. They're angles in the same segment. Now, the last thing now is angle AED. That's this angle here. Angle AED. Now, to tell the truth, I cannot see any way in which you could find it directly. There's no circuit theorem that allows you to find that angle directly. But here's what we can do. You see, if this angle here is 65, this angle here is also 65. So if I want, I could say to the examiner that angle, let's call it theta. Theta is equal to 65 degrees. There are angles in the same segment. All right. So this angle here is 65 degrees. Now, the three angles in a triangle must add up to 180. The three angles in a triangle must add up to 180. So 65 plus 30 plus the angle at E must add up to 180. So it means that angle AED, I'm going to say that angle AED is equal to 180 minus 65 plus 30, and they are the interior angles of a triangle. So this is 180 minus 95, and the AED is equal to 85 degrees. And the AED is equal to 85 degrees. All right. So this is what we are. This was a question, and we just found the final answer on the AED, and on the AED, which we just found out, is equal to 85 degrees.